We have started treating artificial intelligence like a digital deity. You ask it a question and it responds instantly, projecting total certainty. It feels like an all-knowing oracle that holds the definitive answers to everything. But let's look at what happens when you push against the edges of that knowledge. Over at Anthropic, the team building the AI assistant Claude asked it to summarize the research papers written by a specific individual, Jared Kaplan. Claude delivered a beautifully formatted, highly detailed list of titles. It looked flawless. But there was a problem. None of those research papers actually existed. When AI makes things up like this, we call it a hallucination, and it is worse than a simple software glitch. A glitch crashes your program and stops working. A hallucination actively tries to convince you that its fabricated reality is correct, which brings up a bizarre paradox. These models are trained by reading colossal amounts of factual text from the internet. So if they are built entirely on our collective, documented knowledge, why does their internal architecture compel them to invent lies? This diagram shows exactly what is happening under the hood. AI is not a giant database where it looks up saved facts. Instead, it is a predictive text engine. It calculates the mathematics of language to guess the most logical next word in a sequence. Think of it as a highly advanced version of the autocomplete on your smartphone. By reading trillions of words online, the model learns the exact patterns of how ideas typically connect and follow one another. When you ask about broad, well-documented topics, like the moon landing or photosynthesis, this predictive process works beautifully. The center of that probability tree is incredibly dense with data, making the path forward obvious. The system breaks when you ask about something obscure, highly niche, or very recent. Suddenly, that data density drops to near zero. The predictive engine reaches the end of a branch and has no clear mathematical path forward. It behaves a bit like that friend who reads every popular book and takes deep pride in knowing random trivia. When asked about a subject they actually don't know, rather than just admitting ignorance, they throw out a wildly confident guess to save face. This happens because AI models have a primary hard-coded directive: be helpful. Give the user an answer. Faced with an obscure prompt, the AI will scrape together incredibly weak probabilities to construct a polished, confident response, entirely to avoid failing its directive by staying silent. Fixing this flaw requires the developers to reach deep into the backend and rewrite the model's core definition of helpfulness. Over at Anthropic, they are actively retraining Claude to understand that being cautious and honest is the true measure of a helpful assistant. This diagram illustrates their testing methodology. Developers hammer Claude with thousands of adversarial questions. They feed it incredibly niche topics and deliberately tricky scenarios, all specifically designed to trip the system up and force a hallucination. During this barrage, they measure precise metrics. They track how frequently the AI uses hedging language to show uncertainty. They monitor whether it fabricates statistics to fill gaps, and they check how often it successfully recognizes when it simply lacks the requested information. The ultimate goal of this stress testing is to rewire the machine entirely. When a prompt falls into that unknown data category, the predictive text engine should shut down completely, refuse to guess, and output a simple, "I don't know." Each new iteration of Claude improves on this honesty. But the developers are the first to admit this is an ongoing, massive challenge across the entire field. No one has completely solved hallucinations yet. The technology remains inherently vulnerable to making things up. Because the back-end engineering hasn't eradicated the problem, you have to adjust how you operate the tool. The responsibility shifts to the user to actively manage and constrain the AI's behavior. The first tactic is to break the system's relentless helpfulness loop. You do this by explicitly giving the AI permission to fail right in your prompt. Next, you have to audit its certainty. Ask the AI to rate its own confidence level on the answer it just provided. Or better yet, open a completely new chat, paste in the previous response, and force the model to aggressively hunt for errors in its own work. Finally, demand receipts. Explicitly instruct the AI to provide external sources to back up its claims. You must remain deeply skeptical anytime the machine gives you exact details, like specific dates, names, or individual numbers. Applying these constraints works because it artificially lowers the AI's internal pressure. You are giving the mathematical model an off-ramp, short-circuiting its hard-coded mandate to invent an answer at all costs. The very mechanism that makes artificial intelligence so powerful is exactly what makes it risky. That relentless mathematical drive to predict the next word creates a constant tension between helpfulness and strict honesty. We have to stop treating this technology like an infallible oracle looking down from above. Instead, treat it like a brilliant, fiercely eager to please intern. It can do incredible work for you, but it requires strict boundaries and constant supervision to keep it completely honest.
Thank you. Share and subscribe to Learn AI for more AI insights.